Hi class, this is your chemistry video for Tuesday, September 29th. Yesterday we talked about density and gave you the formula for doing that. Today I want to spend the day doing density problems. We'll do a worksheet today, we'll do another one in our live class on Wednesday, and then on Thursday, those of you that are here with me, I want you to we'll do our golden penny, and then we'll do a little bit of another worksheet. And those of you at home, since you did your golden penny last week, I'd like you to work on the worksheet 3 that will be out there on Thursday. Friday, we'll have a quiz on this. Now, this is just working density problems. So it's just our 3 variables, density, mass, and volume. And I want to start right on into this. The first thing I want you to remember is our little triangle. If you're uncomfortable being able to rearrange the equation, please remember your little triangle. And our little triangle, if you remember this, I'm going to put a line across the middle, and I'm going to put a line down like this. And inside of this little triangle, I'm going to put the letters D, M, and V. Right. I'm going to put D over here. We'll put an M up here. And we'll put a V down here. If I can move these into a little bit nicer position so it's easier to see. But I want you to remember these guys. Whoop. Remember this triangle. It'll help you do your calculations. Now, how do we do this? Well, what I'll ask you to do is if you want to figure out what the formula for M is, if you want to figure out the formula for M, all I want you to do is kind of cover up your M. Right? I want to hide that M. And what's left? D times V. Right? If you want to do a different calculation, all I want you to do is cover up that variable. Cover up the variable you're trying to calculate. So if we want to calculate volume, let's cross out our volume for the moment. We see volume is equal to mass on the top and density on the bottom. So D equals M divided by V. This little triangle will help you a lot, not only for this formula, but for a couple others we'll use later in the year. So please get comfortable using it. It'll help you a lot. All right, now let's do a quick review then on the density of a cube. All right, the density of a cube, if we look at that, it's length times width times height. So I'll put an L times W times height. And hopefully that's easy enough to remember. Now, the thing I also want you to see here is what are the units for these, right? When we're measuring distances or lengths, the units are centimeters. So the volume of our cube, there's 3 lengths in there. The volume of our cube will be centimeters cubed. Right? The units for that will be centimeters cubed. All right, I also want you to remember over here that we made a definition yesterday. 1 milliliter is the same thing as 1 centimeter cubed. So when we go between the units of centimeter cubed and the units of milliliters, 1 milliliter is the same thing as 1 centimeter cubed. And finally, let's go our density. We can read it right off of our triangle here. If I cover up the D, what does it tell you? It tells you that density is equal to mass divided by volume. Okay. If I put that in English, mass divided by volume. Okay. Units for mass are usually, so we talked about this a bit yesterday too, so this is a bit of a review. Usually we talk about the units of mass being grams. Let me make my colors different here so it's easier for you guys to see. The units of mass are grams. The units for volume, right? The units for volume kind of hinted at it up here already. It's either going to be milliliters if we're talking about a liquid, or it's going to be centimeters cubed if we're talking about a solid. Right? Remember, because solids we can measure the sides, we're going to measure those in cubic centimeters. Volumes, on the other hand, we use our graduated cylinder. Liquids, on the other hand, we get their volume by using a graduated cylinder. And that's how come we'll get their masses as their volumes as centimeters cubed. So that means the units for density, right, depends on what we're talking about. If we're talking about a liquid, then our units for density are going to be grams per milliliter. If we're talking about a solid, then our units for density are going to be grams per cubic centimeter. All right. So I want you to be careful about that. Make sure you can try to keep those straight. Liquids, their volumes are in milliliters, and solids, their volumes are in grams. So let's do a couple of these problems. And one thing I want you to remember here is we're going to always be concerned about sig figs. We've learned sig figs. Let's use them as we answer these problems. Okay. So what is the density of a chunk of cement that has a mass of 87.6 grams and a volume of 3.07? Now, I find it easier, and I'll ask you to try it. When you're doing density problems, list your variables here on the left-hand side of your answer space. Just list those variables, because then it makes it easier to keep track of what you're doing. Right? At the top here in the word problem, it's kind of buried in the word problem. I don't want you to get confused by that or distracted by that. So as you read the word problem and you have your variables listed over here on the side, I want you to just be able to go, okay, this says mass is 8.76 grams. So over here, I want you to write 8.76 grams. Next one, it says that the volume is 3.07 cubic centimeters. So let's put that one down here. The volume is 3.07 cubic centimeters. Okay. So now what are we looking for? D, we don't know what D is. That's what the problem told us to look for. Right? Well, how do we also can see that right in the problem? Because it says what is the density? Right? So we know that's what we're looking for. So let's do our math. Right? We know that our equation, D equals M divided by V. Take that 8.76 grams, and we're going to divide that by 3.07 cubic centimeters. And what's our calculator going to give us here? Our calculator is going to tell us that this is equal to 2.8534. We're only allowed how many sig figs here? We've got 3 in this measurement. We've got 3 in our volume as well. So we're only allowed to have 3 sig figs in our answer. 3 sig figs in our answer. So here's our 3 sig figs, the 2, 8, and the 5. What's that 3 tell you to do? It tells you to round down, so we're going to leave that 2.85 alone. So our answer round up. Tells you to round up. So our answer here is going to be 8.9 grams per cubic centimeter. So hopefully you're starting to see the pattern I want you to do, the process I want you to do. I want you to somehow mark in the problem, what are your variables? Anytime you see that what, that tells you that's going to be a question mark because that's what we're looking for. So let's plug in what do we know from the problem. 11.4 grams per cubic centimeter. What's our mass? That's what we're looking for. What's our volume? 19.84 centimeters cubed. All right, we're looking for mass. Again, we could go back to our triangle. If we look at our triangle, if we cover up mass, because that's what we're looking for, what are we left with? D next to V. That means D times V. So we can go right here to our problem. I'm going to say mass is equal to D times V. Let's plug in our variables. 11.4 grams per cubic centimeter. We're going to divide that by 19.84 cubic centimeters. Exponents here. And let's double check that we've entered our formula incorrectly. We have grams in the top. Nowhere else do we see grams. We have a cubic centimeters in the bottom of our first term. We have them in the top of our second term. Right? So we know that these are going to cancel each other. Oh, that should be a plus, a times rather. I'm sorry. We have it in the top of our second term. So this, these centimeters cubed are going to cancel. What are we going to be left with here? Our calculator is going to tell us. Calculator is going to tell us 226.176. We're just left with grams here, which is good, right? We canceled our units. We're left with grams, which is right. We're looking for grams. We're looking for mass. So we know we've done our units right, our formula right. How many sig figs are we allowed? We've got 3 for our density. We've got 4 for our volume. We got to pick the smaller number. We got to pick the 3. That tells us that we have 226. Those are the very numbers we're looking for. The one after that tells us we're going to round down. So our answer here is simply 226 grams. All right, 2 to go. Again, we're going to come through here. What is the volume? I want you to identify in the problem. What are your variables? What is the volume? There's the mass, and here is the density. So let's start off again in our right margin. We're going to put density equals, and what do they tell us? 0.950 grams per cubic centimeter. Mass equals 50.0. And that leaves us volume, which of course that's what we're looking for. We could go over to our triangle. We're looking for volume, so we're going to cross out volume. That leaves us an M on top of a D, so an M divided by D. So we have V equals M divided by D. Let's plug in our values. 50.0 grams divided by 0.950 grams per cubic centimeter. Plug that into our calculator. Our calculator is going to tell us, calculator is going to tell us 52.632. And what are our units here? What are our units here? Well, we have grams in the top of the first term. We have grams in the top of our bottom term. So those are going to cancel. What we left with, centimeters cubed in the bottom of the bottom term, which means we've got to flip it up. It means our units here are centimeters cubed, which is good because that's what we measure volumes in. So we know, again, we double checked our formula, we've got the right answer. How many sig figs are we allowed? We got 3 here. We got 3 here, so we're allowed 3 in our answer. There's our 3 sig figs. Look at the next digit. That 3 tells you to round down. So our answer is going to be simply 52.6 centimeters cubed. All right, one more for today, guys. What is the mass? So that's what we're looking for. What is the mass? It tells us our volume and it tells us our density. So again, I want you to start off in your margin. Density equals 6 grams per cubic centimeter. And 1 sig fig in this one. Mass, that's what we're looking for. In volume, 34 centimeters cubed. So we just did a mass problem right above here, right? We see mass is equal to density times volume. Put those numbers in here. Let's do plug our values in. 6 grams per cubic centimeter. And we're going to divide this by 34 cubic centimeters. So let's make our exponents here. I want to get confused that those are actually part of our numbers. All right. Let's punch that into our calculator. What's our calculator? Come back and tell us. It's going to tell you 204. What are our units here? Well, let's see. We have grams. Find no other grams. We have centimeters in the bottom of one term. We have centimeters in the top of the next term. We're multiplying, so those guys are going to cancel each other out. So we're just left with units of grams, which is good. That's what we're looking for. These grams. How many sig figs are we allowed here? We had 2 from the volume, but we only have 1 from our density. So how do we write 204 with just 1 sig fig? Right, here's our sig fig. Here's our, whoop, made that a little bit too big. Here's our sig fig. It's at 2. That 0 tells you to round. The 0 tells you to round. It tells you to round down. So we're going to leave the 2 alone. We're going to leave the 2 alone. Now, we don't want to move our decimal here. Right? So where was that 2? It was in the hundreds place. So how do we make our 2 and our answer to be in our hundreds place? We have to put 2 zeros after it. Right? 200. And again, our units are grams. That's it for worksheet number 1. Hopefully that made some sense to you guys. Again, if it doesn't, please play any part of the video over again. And if this is making sense to you, awesome. You'll do well on Friday. But we'll continue working on this the next 2 days in preparation for Friday's quiz. That's all for today, guys. Thanks.